For number 14, we are asked to find the area of a quadrilateral having the point -3, 4, -2, -1, 4, 4, and 0, 5 as vertices. So to solve for the area, we use the formula 1/2 quantity x sub 1 times y sub 2 plus y sub 2 y sub 3 plus x sub 3 y sub 4 plus x sub 4 y sub 1 minus quantity x sub 2 times y sub 1 plus y sub 3 times y sub 2 plus y sub 4 y sub 3 plus x sub 1 y sub 4. So if we plug in this in our calculator, all the givens here, we will get 21 square units. As you can see in my solution, you can see we just put the given in their respective area. So that's it for number 14. Our answer is 21 square units. For our number 17, we are asked to find the radius of a circle with the center at 4, 1 with a chord of length, which is 4 squared of 2, is bisected at 7, 4. So our first step is to draw. I need to plot our points so that we can draw our circle, and so that we can find the radius. So as you can see here, I've plotted already the given points, and since we have here the length of our chord, we can use it later. So first we need to find the distance between the center and the point 7, 4. So we will have here distance equal to square root of 4 minus 7 squared plus 1 minus 4 squared. So we will now have here distance is equals to -3 squared plus -3 squared. So our distance is equals to 9 plus 9. So we will have here square root of 18. And our square root of 18, we have here 3 square root of 2. Now as you can see in the drawing, we can draw a diagram, and if we divide our chord, the length of our chord, we will get 2 square root of 2. So we can now solve for the radius. We can find the radius using the Pythagorean theorem, since we have our height, which is 3 square root of 2, and our base, which is 2 square root of 2. So we can use the formula a squared plus b squared equals c squared. So our a squared is equals to 2 square root of 2, and our b is equals to 3 square root of 2, and our c squared is unknown. So now we can solve. So we have here 8 square root of 8 plus 18 equals c squared. So we will now square both sides to cancel out the exponent and the c. So we have now here square root of 26, which is our c. Now we have here the hypotenuse of this rectangle, and since it is a hypotenuse, we can say that that is the radius of this circle. The radius is equal to square root of 26. So we are now on number 18. So the radius of a circle is 5, and its center is at -3 and -4. So find the length of the chord that is bisected at -11/2 and -13/2. So what we will do here is, first we need to create a Cartesian plane, then plot our points. So as you can see here, we have our radius, which is 5, and our center here is -3 and 4, and we have the point -11/2 and -13/2 here, and what we will do next is that we need to find the distance from the center to the point which it is bisected. So we are going to use the distance formula. So again, distance formula is x sub 2 minus x sub 1 squared plus x sub y sub 2 minus y sub 1 squared. So now, as you can see here, we have our square root of -3 minus -11/2 squared plus -4 minus -13/2 squared. So if we plug in this in our calculator, we will get 5 square root of 2 over 2, and that is our distance between the center point and the point where they bisected. So now, since we have the radius, we can assume that there is a triangle here, a right triangle. So as you can see here, we have a right triangle, and the hypotenuse of the right triangle is 5, and the height, which is the distance between the point and the other point, is 5 square root of 2 over 2. So we have now the hypotenuse and the opposite, so we can use the formula a squared plus b squared equals c squared. Now it will going to become a squared equals c squared minus b squared. So if we substitute, so a squared is equals to 5 squared minus 5 square root of 2 over 2 squared. So we square both sides so that we can cancel out the square root. So we will now have a is equals to 25 square root of 25 over 2. So if we plug in this in our calculator, we will get 5 square root of 2. And since that is just one side, or the other side of our chord, or the half of our chord, we can multiply it by 2 or add another 5 square root of 2 over 2 to it. So we will get a is equals to 5 square root of 2 units. So the length of our chord is 5 square root of 2 units. Next, for number 19, we are going to find the area of a polygon whose vertices are 1, -4, 4, -1, 4, 5, -1, 4, and -2 and 1. So we to solve this, we have the formula here is area is equals to, as you can see here in the photo, is this formula. So what we will do here is we will cross multiply this, for example, x sub 1 and y sub 2, then minus x sub 2 minus x sub 2 times y sub 1. Then x sub 2 y sub 3 minus x sub 3 y sub 2, and so on and so forth. So we have here 1/2 because we're going to multiply it by 1/2 at the end to find the area. So we have here the points. As you can see, now we can substitute it to our formula. So you can see here we have x sub 1 is 1 and y sub 1 is negative 4, and 4 is our x sub 2 and our y sub 2 is negative 1, plus our x sub 2 and y sub 2 is 4 and negative 1, and our x sub 3 and y sub 3 is 4 and 5, plus our x sub 3 y sub 3 is 4 and 5, and our x sub 4 and y sub 4 is negative 1 and 4, plus our x sub 4 and y sub 4, which is negative 1 and 4, and negative 2 and negative 1. And lastly, we have the x sub 5 and y sub 5, and x sub 1 y sub 1 is negative 1, negative 2, 1, and 1, negative 4. So if we solve this, we will get 1/2 quantity negative 1 plus 16 plus 20 plus 4 plus 16 plus 5 plus 1 plus 8 plus 8 plus 1. So if we calculate this in our calculator, we can get 76. So now we can multiply it by 1/2. So we will get the area is equal to 39 square units. And now for our number 21, we need to find a point on the y-axis that is equidistant from 5, 1 and negative 3, negative 1. So what we can do here is first we identify our points, which is 5, y and 1, that is our a, and our b is negative 3 and negative 1, and our c is 0 and y because it is in the y-axis. So we have here the formula ac squared equals to square root of 5 minus 0 squared plus 1 minus y squared. So we square both sides so we can cancel out the square root. So we have now here 25 plus 1 minus 2y plus y squared. Then we have here next here bc squared is equals to, again, square root of negative 3 minus 0 squared plus negative 1 minus y squared. So we have now here, we can cancel out our square root, so we will get 9 plus 1 plus 2y plus y squared. So if we combine 25 plus 1, we will get 26. Then we can cancel out our y squared, because if we transpose, they will going to be subtracted. Then we are left with 26 minus 10 and 2y plus 2y, because we transpose our y to the other side and our constant to the other side. So now we have here, if we subtract 26 minus 10, we will get 16. Then 2y plus 2y is 4y. So if we divide this by 4, we can get y is equals to 4. We have now here our point, which is 0 and 4.